In this video, we're going to cover the double angle identities and the half angle identities. So once again, we've got a new list of a bunch of identities, kind of a mess. Once again, I don't think it's worth it to try to memorize all of these. Instead, it's better to know how to take these from a formula sheet and apply it to a given problem. These are definitely the type of things that I would include on a formula sheet in my class. However, these ones are actually not that bad to prove using the sum and difference identities from the previous video. I'm just going to show one of these right now. So sine of 2a is 2 times sine a times cosine a. Well, 2a is the same as a plus a. And then from the sine of a plus b, it's sine of the first angle, cosine of the second angle, in this case the second angle is also a, plus sine of the second angle, cosine of the first angle, and notice those are like terms now, so we just get 2 sine a cosine a. So these identities aren't that hard to prove by just using the previous ones and using b as the same angle as a. And then if you want to kind of work your way back, you could do the half angle identities here. But again, I don't think it's worth it to spend too much time proving these formulas. I mainly wanted to show you how to use them to solve other problems. So this first problem here, we say that a is some angle, that the sine of that angle gets you 1/4. And we know that the angle A is in quadrant 2. And now I want to find what is sine of 2 times a, cosine of 2 times a, and sine of a over 2. Now we don't know what the actual angle A is, so we can't really figure out how to do the sine of 2 times the angle, cosine of 2 times the angle. We have to use identities to get the answer. If we knew that A was 30 degrees, then we could just double it, get 60 degrees, and find the sine, cosine, tangent of it. But we do not know that. We do not know what the actual angle is. All we know is that sine is equal to 1/4. Since my identities for these up here do include sine and cosine of a, the first thing I want to do is figure out what cosine of a is. So I'm going to draw myself a triangle here. I'll call this angle A. Then sine of angle A is 1/4, which is opposite over hypotenuse. We go ahead and use Pythagorean theorem and get square root of 15. And so I would say cosine A is square root of 15 over 4. That's a quick and easy thing to do here. I do want to point out that it in fact is not correct. So we did the right work, but I made the wrong conclusion. And we have to pay attention to the fact that A is in quadrant 2. So the real picture on a unit circle is I am in quadrant 2 over here. And so my opposite and my hypotenuse are over in this picture, which means A is in fact not the angle there. It's the reference angle for A is the angle in my triangle. And since I'm going to the left here, it's actually going to be a negative root 15. So my cosine is going to be a negative square root of 15 over 4. So keep in mind that the signs could be positive or negative, and you have to know which trig functions are positive or negative in which quadrants. That's something we covered in the past. Now that we have this, though, we can finish the problem. So sine of 2a is 2 sine a cosine a. Sine A was 1/4. Cosine A is a negative square root of 15 over 4. And so it's going to work out to be negative square root of 15. So on the bottom, we'd have 4 times 4 is 16. But 1 cancels 2 on the top. We get 8. So sine of 2a is negative square root of 15 over 8. If I want cosine of 2a, I can choose any one of those three formulas. I'm going to choose the third one. It's 1 minus 2 sine squared a. Sine of a itself is 1/4, so sine squared a is 1/4 squared. That's 1 minus 2 times 1/16. 1 minus 1/8 is 7/8 here. So that's cosine 2a. And the last one is sine of a over 2. That's this identity. And now we get to the extra complication when you have sine or cosine of a half angle. And that's that weird plus or minus in the formula. And so the way you have to handle that is the answer is either going to be plus or minus, but it's going to depend on what quadrant you end up in when you take half of the angle. And so you have to ask yourself, okay, if I'm in quadrant 2, this is where my angle A is in quadrant 2, that means A is somewhere in between 90 degrees and 180 degrees. And so if I half that, if I take the half angle, I'm somewhere between 45 degrees and 90 degrees, which means I'm somewhere in this region, 45 to 90, and we know in quadrant 1 that the signs are always positive, so that means the sine of a over 2 is going to be the positive version here. And so we're going to get the square root 1 minus the cosine, which is negative square root 15 over 4 all over 2. And I'm honestly not going to try to simplify this. There's not much you can do here. I'll just leave it as this mess. But this would be the value of sine of a over 2. Okay, so we can find double angle or half angle using the identities. And it is important at all times to keep in mind what quadrant we're working in so we know if things are positive or if they are negative. That's something that's easy to overlook. Now for the second problem here, we are trying to prove a trig identity using these double and half angle identities. We can choose to start from the left or the right. I honestly don't see much preference here for left or right. I'm going to choose to start with the left. I'm going to do what we've done many times before and convert things into sines and cosines. So we have 2 cosine x minus, and then secant gets replaced by 1 over cosine x. I'm then going to go ahead and make them both into fractions with common denominators. Multiply top and bottom by cosine x here. We get 2 cosine squared x over cosine x minus 1 over cosine x. That becomes 2 cosine squared x minus 1 over cosine x. Then I can see this right here is 2 cosine squared x minus 1. That's exactly going to be cosine of twice the angle. And then the bottom cosine x is still there. And that matched what we're trying to go for, and so we've proven the identity. So again, we're just showing you how we can use these new identities to prove other identities as well.